So welcome to Unit 2 Lesson 6, stretches about the x or y axis part 2. This first part here is a little bit of a review, so I suggest you read over it and then we'll start with the lesson. So after reviewing the part above here, let's just move on to class example 1 in your workbook. Write an equation of an image of y equals x squared after a horizontal stretch about the y-axis by a factor of 3/4. So what does that mean? It's a horizontal stretch, so the multiplier is affecting x, and when it's beside x, it always looks opposite to what you'd expect. In other words, it's the reciprocal, so x goes to 4/3. So we pop that value in for x here, and we get 4/3x is then being squared. Or you can multiply this out. If you're squaring everything, it's 16/9x squared. Part B, y equals the square root of x minus 3 after a horizontal stretch by a factor of 4 about the y-axis and a vertical stretch by a factor of 2 about the x-axis. So two things are going on here. First, horizontal stretch by a factor of 4, so you're affecting because it's horizontal, you're affecting the x by a factor of 4, so x is going to 1/4 x. The next thing is a vertical stretch by a factor of 2, so y goes to 1/2 y. So first of all, we will take y value and substitute it in. So it's into this equation, y equals x squared, becomes half y equals, and x gets replaced with 1/4 x under the root sign minus 3. So if we multiply both sides by 2, we'll get y equals 2 in bracket square root of 1/4 x minus 3. Multiplying at the bracket, we get the following equation. And then we can take the square root of 1/4. It's just 1/2. So 2 times 1/2 is 1. Ends up just being y equals the square root of x minus 6. So notice, even though we do the replacements here into the equation, we still need to simplify this equation until we get our simplest answer here. So this is actually a square root function that's actually been shifted to the right by 6 units. And we had started off with this function square root of x minus 3, which is actually to the right of the y-axis by 3. So in all, it just looks like it seems like it's just a shift 3 units to the right by 3, comparing this with this. Part C, y equals 3x plus 7 after a vertical stretch by a factor of 1/3 and a reflection in the x-axis. Vertical stretch affects the y, factor of 1/3, so y goes to 3y. It's also a reflection in the x-axis, so all values on top of sorry, for reflection in the x-axis, it means all y's basically switch signs, so y goes to negative x. So what does that mean? This y here would become negative y, or negative 3y. So we're finally, these two combined means that y goes to negative 3y. We can plug that into the equation. Negative 3y equals 3x plus 7. We'll divide both sides by negative 3, which means you're really multiplying by negative 1/3. Multiplying at the brackets, we'll get negative x and minus 7/3. So just take a moment to review that and understand what's going on in those examples. Class example 2 is asking us to describe how the graph of the second function compares to the graph of the first function. So first function is y equals f of x, and what's happened here is goes to y equals f of 1/2 x. So this is something to do with the horizontal because it's multiplying the x, and we know that multiplying it by x by 1/2 means it's a we're actually expanding it by a factor of 2. Replacement terminology would just x would go to 1/2 x. So here it is, a horizontal stretch by a factor of 2, and of course it's always, horizontal stretches are always about the y-axis. Part B, y equals 2 to the exponent x. X has changed here to 3x, so the replacement is x goes to 3x, as written here. The 3 means we're basically compressing by a factor of 1/3. Horizontal stretch, factor of 1/3. Part C, we're using the absolute value sign. What's happened? Outside the function of the absolute value, we're multiplying it by -2. So really we can bring the -2 to the other side. It would be -1/2 y equals the absolute value of x. You can see from this there's two things going on, and that the negative just means it's a reflection in the x-axis. All the y's are becoming negative now. And the half means it's going to be an expansion vertically by a factor of 2. Vertical stretch by a factor of 2. Replacement terminology is here. So y has been replaced by 1/2 y, and then the y itself has become -y. Basically, that's to do with the vertical stretch by a factor of 2. Y goes to 1/2 y. And about the x-axis, a reflection means y then goes to -y. So overall, as we've seen, y goes to -1/2 y. Part D, similar things going on. We've got x cubed goes to y equals x cubed goes to 3y equals x cubed. So the multiplier is 3 right beside the y, so it does opposite to what we expect, in that it's a compression by a factor of 1/3, vertical stretch by factor of 1/3. And that's about it. It's no reflections or anything. Part E, y equals modulus, or the absolute value of x, changes to y equals 2 modulus of 1/3 x. So two things are going on. We can rearrange the equation, bring the 2 to the other side if we like, or just read it the way it is. This 2 really means it's a expansion vertically by a factor of 2. This 1/3 beside the x really means it's an expansion horizontally by a factor of 3. Here's the replacement terminology beside it here. F, absolute value of x. Y equals absolute value of x goes to y equals absolute value of -2x. X has been replaced by -2x. So the the 2x, first of all, means that we've got a horizontal compression or stretch by 1/2. The negative means that excuse me, x has gone to -x. So that's a reflection in the y-axis. The y-axis. Okay. Example 3. The function represented by the thick line is a stretch of the function represented by the thin line. Write an equation for each function represented by the thick line. So look at the thin line and see what's happened. Looks like it's a compression. This point, it looks like at a height of 6 has gone down to a height of 3. So it's a vertical compression. This is the equation here. So it looks like y has been replaced with 2y. And here we are. That's exactly what's going on. So we take this equation up here, this equation we have here, and we replace the y with 2y, we'll get this. So dividing both sides by 2, then we'll get this. You can multiply that out. Really, 1/2 times 6 gives you 3, so you finally get this equation right here. Okay. Part B, what's happened? You've got this curve. So here's the curve down here. It started at positive 3, it's gone to negative 6. It looks like a couple of things are going on here. Could it be a reflection in the x-axis or the y-axis? So it looks like you've got two things. It looks like a reflection in the y-axis and then a reflection in the yeah, not sure what that is. I have to think about that one. I think there's three things going on here. It looks like this curve goes over to this side, so we want to reflect it so it's over to, comes around here, like that. And this line will go down to here, sorry. And then we get reflected, and so we end up with, if we reflect again, we'll get a curve that looks something like this. And we'll get a line that looks like this up to here. But then there's a stretch going on, so it looks like then there's a vertical stretch. I guess I've missed this straight line part here. So there was a straight line, so that would be out like that. And if I did it in blue, the other one would have been out here. Okay, so two reflections, so you can see that it's mentioned on the side. Vertical stretch by a factor of 2, you can do that first, about the x-axis, and then a reflection in both the x and the y-axis. So here's the replacement terminology. Basically y goes to negative a half y, because you've got the reflection in the x-axis and the expansion by 2 vertically, and then a reflection in the y-axis, x becomes negative x. So with this equation, y equals f of x, we get the two things replaced. We can bring the negative a half to the other side, it becomes negative 2 on this side. So take a moment to think about that. A little bit complicated, just pause the video and have a look. Okay, so this is a very similar thing. You can see from the equation that we're going to have zeros at negative 4 because of this bracket, positive 2, positive 6. In the original, here we are right here at negative 4, positive 2, and positive 6. So what's happened is it looks like it's a stretch horizontally. This has gone over here. So 2 has gone to 4, 6 has gone to 12, negative 4 has gone to negative 8. The heights are still the same, so it just looks like a horizontal stretch by a factor of 2. So what's happened is that x has gone to a half x, and those get replaced in the original equation, so all the x's get replaced by a half x. This can all be multiplied out, or you can factor out the halves first of all. Half times a half times a half is an eighth. And you still then have, now be careful, when you factor a half out of here, the 4 would turn to 8, the negative 2 would turn to negative 4, and the negative 6 turns to negative 12, factoring out a half. So your final equation would look like this. And you can tell the zeros would be negative 8, positive 4, positive 12. Okay, last example here. Polynomial function has this equation. Determine the zeros and the y-intercept if the following transformations were applied. Okay, so we're starting with this, and instead of p of x, we've got negative 3 p of x. So a reflection in all the y's are becoming negative, so a reflection in the x-axis, and looks like a vertical expansion by 3. So zeros of px at the moment are 4, -3, and -6 to begin with, as you have up here. And the y-intercept of px would be putting these in for when x is 0, 0, 0, 0. When x is 0, we can find y, because the y-intercept x is at 0. So you end up with -4 times 3 times 6. The y-intercept is -72. So what's actually happening, we can see if we bring this -3 over to the other side, we can read it like that. Vertical stretch by a factor of 3 and a reflection on the x-axis. So there's not going to be any change to the zeros themselves because of a x-axis reflection. Anything on the x-axis stay put. And a vertical stretch stretches about the x-axis itself. Nothing on the x-axis moves in a vertical stretch. So no change to the zeros. However, notice that the y, it's a vertical expansion by a factor of 3, or -3. What the value was for y originally at -72 gets multiplied by -3. And so we get 216. So here's the zeros, they stay the same, the y-intercept changes. So why don't you try this yourself in part B? Here are the answers. You try and figure it out without looking at the answer. And if you can do the assignments, questions 1 to 6 for lesson 6. And we'll see you in class.